friends. So in this video, we're going to solve Leetcode number 27, remove element, and we're going to discuss all the possible solution in Java. This is a frequently asked Leetcode question in the interviews, so I decided to solve it. Let's understand the problem statement first and see how we can tackle this problem and discuss about different solutions, easier ones, optimize, brute force, and so on. So let's go through the problem statement. So we have been we are given integer array nums and an integer called val, and we need to remove all the occurrences of val in nums array. And they say we have to do it in place. So what is basically means is that we cannot use any extra space to do this operation. So we are given array, we are given a value, we need to remove those values from the array, and we have to do that in place. That means we cannot use any extra uh, space to do that. And then they say that the order of the element can be changed. They don't care about that. And then um, we need to return the number of elements in num which are not equal to val. So there's acceptance criteria here, which says that change the array num such that first k elements in that num array contains the element that are not the val. Basically, should only contain the value which we are uh, not removing, and then remaining elements in the num array can be anything. They don't care about it, and we need to return the k element. Looking at the example, we are here we have been given 3, 2, 2, 3. We need to remove 3 here so that our output should contain 2, 2, and underscore basically here telling us that the um, code just doesn't care about the remaining value. And why and how they don't care about that, we need to return k here. So basically telling that how many elements in the array we should consider for the evaluation. So k equal to 2, basically telling that only 2 elements are the element that the code judge should consider, and the other elements can be anything. Coming back to the example number 2, we have been given this long array, and then value 2 is the value that we need to remove. So if you see in this array, it doesn't contain any 2 in the initial elements, and all the underscores are marked at the end. So they are technically the one that we removed, and we push down that to the end of the array. And k is telling us that how many elements in the array matters for the evaluation. So yeah, that's the pretty much the problem. And like this problem would be very easy if we have not been told to use we have not been restricted to not to use like any memory or any extra space. How we would have solved in that case? In that case, it would be easier to just to retrieve through the nums array, find out the values that are equal to uh, val, filter those, and output the resulted value into the new array or new list. A Java streams API would be very helpful here. Just a simple filter command and then a filter operation and map it to the result array. But that's, yeah, in this case we are using the extra space, so that would not solve the given problem. But yeah, it will give you the output that basically needed. So let's see how we can solve this problem, still solve the problem in place. We're going to discuss two approach, brute force, and then there's optimize one, two solutions. The brute force approach is it's not that tricky. So if we see at our array, what we would do as soon as we reach to a element that matches to the target val. So in this case, 0 element is at the correct position, 1 element is at the correct position, but 2 we need to remove. But we cannot just blindly remove this with anything else, and or any yeah, any element. We need to make sure that this element is the element that is a valid element for the result. But we won't be sure until we replace this element with something in the rest of the array. So what if we left shift our array for this position? We left shift our array. So we replace 2 with 23042, and then we put this 2 at the end. So shifting the rest of the array to the result would make it so let me draw this. So yeah, we left shift the rest of the array to this position, and we again evaluate the element at this position, because potentially when we left shift it, doesn't guarantee that the first element that occupies this place is the right element, because as we can see in this example, when we left shift, the element that got left shifted is also the same element, so that will end up giving us the wrong answer. So we have to again evaluate the position, and we have to do till we find out the right element. So basically left shifting the entire array till we find the right element, and we need to do this operation for every element where we find the target element or target value equal to 2. So yeah, that's the whole approach. So let's see the code here. First, we are capturing the length of the nums. That will be handy to do two things. First is operating over a for loop, and second, we also gonna use this element to return our final length of the resultant array. So while iterating over each element, whenever we find value, whenever find the nums of I equal to val, basically a target val, then we going to left shift it. And what we need to do for left shifting, we need to operate a for loop for the rest of the array and assign j equal to j plus 1. That is basically copying the element from j plus 1 to j. That's a left shift operation. Now we also spoke about that left shifting the element does not guarantee that the element at the current position is going to be the right element. So for that, we need to decrement our current element, a current position. Why? Because then I plus plus basically advancing the index to the next position so that it nullifies it, right? So from the current position we go one back, and then I plus plus essentially makes it the current index. Then we have to decrement the length because we found one target element matching to our matching to the well in the question, and then we return that. So that's the brute force approach for removing the element. Let's quickly talk about the time complexity and space complexity. Time complexity. So the outer loop makes it O of n. Inner loop that we see here is for left shifting, and potentially we can left shift for all the elements in the array. So if we are given if we are given like nums array that has all the elements filled with the val or target val, we have to do left shift for each of those, and it will end up uh, with the time complexity of O of n square due to like the repeated shift. And the space complexity, since we are not using any extra space, it is constant, that is O of 1. So that's the brute force approach, and it works, but the complexity is bad. Bad as in like it's O of n square, and we can reduce that to O of n using the optimized approach that we're going to discuss next. So what's the optimized approach? So let's go back to our example to discuss that. So we have this array. In the optimized approach, we will have a two pointer pointing at start of the array, left pointer and right pointer. The job of the left pointer is to fix the position, making sure that the position has the correct value, and job of the right pointer is to scan the array and find out the places where elements are at the rights. The elements in the array are the correct position. And whenever there is an element which are not at the correct position, it will uh, basically swap with the element which is uh, correct, which is the correct element. So the approach would be, we define a left pointer and right pointer, and in the array whenever we find whenever we see a element that is not a val, meaning that this element uh, is at the correct position, we swap that. Then we move forward, a left pointer and right pointer both. Now what if the right pointer is at the value which is like a target value that we need to remove? Basically, in that case, the right pointer would keep moving forward till it finds the next correct val that we can swap back. So coming back to example 0, 1, 2, 2, 3, 0, 4, 2. So initially they both will be at 0. Right pointer will move forward. It will find that, oh, the 1 is the right element. It is not a val equal to 2. So it will assign the left pointer to this, saying that this is at the right position. Now it will move forward to the next element, and as we can see, the next element is 2, basically telling that the 2 should be removed. So right pointer will move forward, and keep in mind that the left pointer at this position is at 2 as well. Why? Coming back to our example again, as we can see, whenever we basically swap the element left pointer right pointer, we increment the left pointer by 1, right? So whenever we when right pointer reaches to 2, left pointer is also at 2. But the interesting thing is that since this is the value that is not a target, this is the value, target val, it doesn't increment the left pointer. So left pointer is still here and right pointer moves forward. It moves forward till it finds the value which is not val. So left pointer will be at 2 and right pointer will be at 3. And once right pointer finds out the value, correct value, it will swap with the left pointer. So 3 will be swapped with 2, and then that's how we fix this position. Now left pointer will move to the next element, which is 2. So as we can see, the left pointer's job is to fix the position with the correct element, and right pointer job is to find that correct value. And once right pointer ends to the array, it basically swaps all the position with the correct value, and the remaining values in the array would be um, basically the target values, and the left pointer will be at the position, basically telling the how many elements in the array are left with the correct value. So that's what it returns eventually. And yeah, that's the all code for this approach, which basically reducing the overall time complexity from O of n squared to O of n, because the we are iterating through each element only once, and making efficient use of two pointer, right pointer, scanning through all the nums array, finding out all the elements that are correct, and uh, left pointer job is fixing those position with the appropriate value. So time complexity brings back to or boils down to O of n, because we are not doing like any uh, left shifting of element and so on. Space complexity remains O of 1, since we are not using any extra space. So yeah, that's the whole logic for the optimize approach. So now coming back to the summary, what we did. So we discussed about solving this problem without like with extra space. Basically, simple Java streams filtering all the val out of the nums array and then mapping that back to an array with only the correct values and returning the size. The second thing we talk about is brute force approach, where we are iterating over each element. Whenever we find a value that we need to replace, we left shift the whole array, and again evaluate that and repeatedly check that to make sure that the position is filled with the right value. After that, we discuss about the optimize approach. In the optimize approach, we talked about having two pointer, left and right. Left pointer basically fixes the position with the correct value. Right pointer finds the right value that left pointer should replace with, and that's how this two pointer make sure that we are having nums array filled with the initial nums array filled with the correct value uh, in the prefixes, and then all the remove element push back to the last. Yep, that's the whole thing about this problem. If you want to visit, this is I also wrote a blog about this, so if you want to have a second pass on this, feel free to read through it. But yeah, that's it for this. See you in the next one.